Okay, so I'm working at my computer from home, so my H file, and I actually need to rename this to a C file here. My H file and C file are a little bit different, um, and MPL, this should actually be MPL115A2, and this one should be MPL115A2. Okay, so I got my names correct here. These files might look slightly different than the ones we did in the other video, so I'm going to go through the header file quickly because I'm at my home computer, as I said. And so we have here at the top the macros, which these should all be the same. My names might be slightly different than what I did in the original videos. Because I'm working on this one, you might want to pause it and make sure all your macros look like this. It might mean inserting another underscore, because if you're going to be coding what I'm doing here, you're going to want to follow the same macros. And then we had this command here. This is the command to actually take a measurement from our pressure sensor. And then this here, I think we might have forgotten to put this. We needed to also have a macro of what the actual device address is. So I know how to actually access the device, which is 0x60. Then we have the three functions here. What I'm actually going to do is we're going to write code for these two functions and test it. And then your assignment is going to be to write code for the get temperature one. And then we have global variables that we'll need, because these coefficients, we're going to determine what these coefficients are in the start function, because we only have to read them in once, but we need them in the formula for computing pressure. So just kind of to remind you here, let's go back to the data sheet here. Let's even zoom in a little bit. Here, we'll go back here, but basically you can see here how to do the compensated pressure from this formula, and then how to get the pressure in kilopascals with this pressure, with this formula, I mean. And it kind of goes through a way to compute it. I mean, you can use this formula. We're going to do it a slightly different way, because you'll need to define a whole bunch more variables to do it this way, and we can just do it in one line. So that's what we're going to be doing here for this thing, is we're going to be reading in the coefficients here on this video here. We're going to write the code for that. And so again, you want to make sure that the variable names, and I've also predefined them here to be 0, which I don't think we did in the other one. Usually by default they're 0, but I want to basically make sure they're 0, because when I'm reading in the coefficients, I'm going to be doing bit shifting, and it's just easier to make sure everything starts with 0, especially when we start debugging this to see if it works correctly. Because we'll be able to see better how it works correctly once we get into using the LCD display, because we'll be able to actually then display whatever the pressure is on the LCD screen. All right, so then let's go ahead and go back to the C file here. All right, so you want to maybe review some of the videos. I know I got a little behind in making them, but you might want to review the videos, especially the one on how we're going to read the data in here. So, we should put in function name and description and usage here, but I'm just going to put in the description here. This function reads the factory set coefficients. This must be called before you take measurements. Before you do the get pressure or get start function. So in other words, or you could say this function, this must be called, instead of before you take measurements, this must be called first, let's just say. And then you could put the usage here. You're literally just typing a line of C code in here for usage for this comment. So if we do this here, it would literally be MPL115A2 start. That's how you use it, because it's a void function. But it's going to read in those global variables for it. All right, so let's go ahead and start doing this here. So first off, I went ahead here, and I should go back to my top design here and actually recall this instead of I2C underscore 1. We called this just I2C. It's a master. So let me rebuild the project, generate my application so I can get the APIs correctly. And remember, you don't have to place the pins for the I2C because they're automatically placed in the correct position. And now, that's the main file going in here to the C file here. We have to read in the data. So the first thing we're going to do is set the pointer in the MPL115A2 to the correct register so we can read data. This requires a write command. Okay, so what we need to first do here is we're going to do I2C underscore master. Actually, I2C, I don't think I need another. Yeah, master. Send start. Now we need the slave address here for it. So the slave address, of course, is the MPL underscore, 115AT underscore, and you can see the list here of the macros. That's because we included the header file, and I can just auto-complete it with that. So that's my slave address. Now I need to tell it whether I want to do read or write. And so I need to do I2C, I think it's I2C write. Yeah. So I2C write exfer mode. X is transfer mode. So, I mean, it's literally just a 0 or a 1. And if you hover over this, I think it might, well, it's not doing it here. We'll see if I hover it over. It might give us what the actual value is here in a second. And then the timeout. How long do we want to let this function operate? Now, we said in real life we might want to actually put a timeout so that we don't just hang in the communications here. But if we put 0 here, remember that means it's just going to wait indefinitely. So there is no timeout. Now, there is a return value for the send start, if, again, when you're getting into more advanced things. Like, for instance, if there's an error when it's trying to send a start here, there will be an error code set, and then you can examine the error code to see what went wrong, whether it wasn't able to start, whether it hit your timeout. But, of course, we're going for infinity, so we're never going to have a timeout situation. All right, so that basically starts the I2C bus. It's basically now sent a signal out to the pressure sensor saying, I want to talk to you. Okay, so then, basically this command completes when the pressure sensor sends a byte back to the board and says, yes, I'm ready for you to talk to me. And so now it's ready to talk to you. We can just do I2C master, and we're going to do write, and we're going to write a byte of data. Now, remember what we're doing is we're trying to get it to point to the correct register. Well, right now we're reading in the coefficients, so I should do 115A2, and actually we have the A0 here. Now you're actually going to read in the most significant byte first. That's what we're going to do. So we're going to read in the most significant byte and then have a timeout again of 0. Now I actually have to go back and fix something here because this reads in the data, but I need to store that data somewhere. I can't store it in the float, the global variable, because this returns an integer. And so what we're going to do is we're going to create an unsigned int. I'm sorry, the write data I'm thinking of read data, but we'll go ahead and do this. When we get to reading the data here, we're going to need to store this. So we're going to have some unsigned ints here, and I'm going to create this as A0 data, and I'll initialize it as 0. And then I'm going to put 3 more here, and I'll change these names to B1, B2, and C12. Then I'm also going to put in here an 8-bit unsigned int, because that's what's going to happen when I start reading the data from the address, from the registers. I need a place to store it. So let's go back to these 2 lines of code. So these are variables that we're going to just use to store some data temporarily so we can compute the coefficients. So let's go back here. Again, what did we say? The first thing here is we're setting the pointer to the correct register so we can read data. So we send a start, we put it in transfer mode, and we say, okay, we're going to wait indefinitely for this command to finish. Then we write a byte, and we write a byte of what's the first register, and you can even see it's got a 04 listed there. What's the byte of the first register we want to read at? And it's at 04. Again, we're letting it time out forever. So this is always going to execute until it's finished. And actually you can see here that for the I2 write transfer mode, it's just a 0. But that's, again, so in order to try and remember that, you don't want to have to necessarily remember it, which is why we just do the write transfer mode here. It also makes the code easier to read. But now we're ready to either, there's 2 options we have at this point. We can either stop the I2C bus or restart it in read mode. I'm going to just simply restart it in read mode. Really, we should only stop it at the very end of a function. So for instance, we will need to stop the I2C bus when done with this function. And the reason we want to do that is we don't know how the person who's writing their code is going to use this driver. They might start the I2C, they might start the pressure sensor, but then they might also start an LCD screen before they actually do a pressure measurement. And so we have to make sure that we free the bus up by stopping the read or write mode, which basically allows the master to then start communicating with another device. So for now, we're only communicating with one. So we, again, just to review, I know I'm going lengthy in this, but I want to make sure we all understand what's going on here. We send a start, and we send to where we want to read the data. And we want to read the most significant byte first of A0. Now we're ready to read data. So I need to put it in read mode. And since I didn't stop the bus, I have to do a restart. So there's a send restart. And then I can put the address here, MPL115A2 address. And then I2C, I2C. I can't type right now, apparently. I2C. And then you can probably guess it's going to be read transfer mode. And we're also going to do an infinite timeout. So now we're ready to read beta. So we're going to read the first, we're going to read the most significant byte of A0. So we'll do I2C, and I'm going to put a lot of comments in here just so that you know for sure what it is we're doing. Master read byte. And then we have to do some kind of, it says here, NAC. So maybe what we need to do here is I'm like, well, what is that? So I should maybe go back to my top design here and go to my data sheet and pull up the I2C and go to my APIs and scroll down to this read byte and go to this and how it goes here. So reads 1 byte and generates an ACK or prepares to generate a NAC. The NAC will be generated before a stop or restart condition. Okay, so basically, if we want to continue reading data, we send this command here, or this button thing. We generate an ACK. Basically, it's an acknowledge. So basically, this is notifying the slave that, hey, I've got that data, but I'm going to be reading more. So I'm going to be reading more from you. So just be prepared. If we send the NAC, basically it says prepares to generate MAC. The master will notify the slave then, by giving a knack command that, hey, I'm done reading data, get prepared to either get stopped or restarted. So it knows that, okay, I'm not going to continue reading data. All right, so those are the two things we need to look at here. So if we go back here to the code, I need to generate an acknowledgement here. So I'm going to do I2C, and there is the ACK data, which is what it was here, ACK data. So that's the acknowledgement, because I'm going to be reading more than just the most significant byte. I'm going to be reading 8 bytes of data. I've got 4 coefficients I have, and each of these take up 2 bytes of data. So I'm reading 8 bytes. Now I have to put in the memory address of where I'm going to store this data. So in other words, what I'm going to do is I'm going to put @data here, because I'm going to store the read in this just dummy variable data for now, saying, okay, I'm going to store it there temporarily in this unsigned integer, and then I'm going to put, again, that I'm going to have a timeout of infinite. Okay, so now what I need to do is I need to put that into my actual A0 data. So this is going to be equal to data, because that's just what I did. But then it's the most significant byte. If I just did it like this, it would put it in the least significant. So I'm going to bit shift it to the left 8 bits, because it's got to be in, you got to think of it, it's got to be in 15 through 8 as far as the bits, if you're looking at that whole 16-bit A0 data. So I bit shift it to the left 8 spots, and then it's going to get stored in there. And this will make a lot more sense once we do a debug on this here and run the code. In fact, I'm going to just read in the A0 data and debug this to show you how it works, and then we'll continue on with the other data. All right, so then I need to read in another byte of data, because I need to read in the least significant byte. But remember, when you read in data here, let me get to the right thing here. When I read in data here, I was pointed at this address, so it read in the most significant byte. The pointer automatically moves to the next location. So now the pointer is saying the next byte of data I'm going to read for you is A0 least significant byte. And that's the reason why it stores it most significant, least significant, most significant, least significant. So it's going to just keep, the pointer's just going to keep moving down. So I can just do a bunch of read commands to read all of this data in. So let's go back here. So I'm going to read the least significant byte in. And I know this video is getting long, but that's okay. And so I'm going to do I2C master read byte, I2C, and I'm going to still be doing more acknowledgement, because I'm still going to be reading more data. I'm going to still store it in that temporary storage location of just data, because it's an 8-bit data. And now I've got to put it in to the A0. So I'm going to do A0 data equals A0 data ORed with data. Because what that's going to do is that's going to push those least significant bytes into positions 7 through 0 of it. And so let's go back here and see if we can get this to debug properly here. So what I'm going to do here in my code here is I'm just going to do, I'm going to first, you have to make sure to include the MPL115A21.h. And I'm going to go ahead and execute the MPL115A2_start command. Okay, so I'm going to put this in debug mode here. So it's going to compile in here. Apparently I've got to tell it here which one to go to here. I must have more than one connected. And I'm now going to also, at the same time, what's my exit code here? Why is it giving me an error? Let me pause this here and figure out what the error is. All right, so I found my error here. I did one thing incorrectly here. It's actually bad practice to declare variables in header files because you can get multiple copies of the variables. So we still want to define them in the header variable, but what we do here, I've gone back to how we do this with an extern command. That's basically telling that I'm going to be defining these as global variables and they're floats. And then in the MPL C file, at the top of the C file here, actually I should put this above here, above the functions. We declare the global variables in the C file. What was happening is I was getting multiple copies of these global variables being defined, and so I was running into some problems. So now that we got that back, I'm still going to get warnings because it's going to say, hey, these things aren't being used, but I'm going to go ahead and do a debug here. And then I'll still get those warnings, which is fine, but it's going to start up in debug mode. Now it's got these registers here and everything, and again, you can look at the locals. What I'm going to do is I'm going to go into the MPLCC file here, and I'm going to put a breakpoint right here at the send start. So I'm going to go in there, so now it's right there, and you can see it gets A0 data and data. Now you might say, where's B1 data, B2 data, C12 data and everything? They're not there anywhere. And the reason they're not there is because it said warning, they're not used, so it didn't declare them. And we can actually have them listed, and I'm going to list these in binary format here so we can see exactly what's going on here. So first off, we're putting it in transfer. We're wanting to make sure we set the register correctly. So I'm going to skip down here to this one, put another breakpoint in here, hit the play button so it executes those 2 lines of code. Then I'm going to do a step over because that will just go to the next line of code. Okay, so it's in the next line of code. Now I'm going to read data. And it didn't because I'm an idiot. I'm going to stop this and restart it because I don't have the sensor connected to my board. So let me pause the video and connect the sensor up. Okay, so now I've got the sensor connected here. I'm going to restart it. As a side note, these sensors you can find in a bin in the lab. I believe it should be by the printer. At least that's where I told my lab TA to put it. If it's not there, I'll make sure that it gets put there. You can hold on to the sensor and like take it to work on it at home and stuff, but you must return the sensors at the end of the semester. And we put in connectors so that you really just need breadboard wires to connect them up. So you actually need 4 breadboard wires to connect it up properly. You need 2 to connect up the SDA and SCL lines, which if you're looking at the bottom of it with the USB port at the bottom, they're on the right side, the very bottom 2 pins, the SDA and SCL line. You need to make sure to put them in correctly. The other 2 that you need to do is you need to power it up. So you need to use that 3.3 volt external and ground, just like you did when you used the potentiometers. All right, so let's restart this again here in debug mode so we can actually read some data in here. It's not going to read data in if you're not connected to anything. Okay, so I'm going to step over. I'm going to step over again, and it didn't read any data here. So let me step over again here. Okay. Well, I'm going to stop this video here for now, and at the beginning of the next video, I will explain there's something else that's not going on correctly here that I'm going to have to fix. All right, and I'll explain what's going on.